So now we're actually going to label the unit circle. If in your lesson, there's a page that kind of describes this and how we would do it in class, I'm just going to kind of explain everything on here. So I'm going to start out and just do the parts we already know. So we know the quadrantal angles in degrees, and we're going to put the degrees in here on this picture. There's little spots on this diagram for each of those things. Now we could also say that this is 360 degrees if we went the whole way around the circle. Then I'm going to work around for those special angles. And remember, we said if this is 30, the other side, if we go back from 180, right, 180 minus 30 is 150. 180 plus 30 is 210. And 360 minus 30 is 330. In the same way, if this is 45, this would be 135, 225, and 315. And then if this is 60, we would have 120, 240, and 300, because each of those come from going 60 degrees away from the axes. Now, if I was labeling this, I might just go in a circle with those, but that's how we think about them. So once you know them, you could just label them in a circle. So now I'm going to move out to the radians. So we have 0 and 2 pi. Cut it in half is pi. Cut that in half is 1/2 pi, which we write as pi over 2. And in between 1 and 2, we have 3/2 pi, or 3 pi over 2. Then we learned the different values at the 30, 45, and 60. And I'm going to write those in because that's how we learned it. So I'm going to try to keep my colors consistent. 30 is pi over 6. 45 is pi over 4. And these were also ideas of fractions of the pi over 2. And then 60 was pi over 3. To get those angles that used 30 as what we call their reference angle, here we would just think of this pi as whatever fraction we need. In this case for 30, I need 6 over 6 pi. I'm just going to write that in and I'll erase it later. So 6/6 minus the 1/6, when we subtract that 30 or pi over 6 gives me 5/6 pi or 5 pi over 6. If I add it in this direction, just like we did to get to 210, I would get 7 pi over 6. And then if I go back from 2 pi, we know 2 pi is equal to 12 over 6, or 12 pi over 6. If I subtract the 1/6, I get 11 pi over 6 down here. There's 2 pages ago in the packet, that very first page of this lesson, there's more of a description of that. From here, we are going to do the 45s. I'm going to erase the fractions I used for subtraction over here. And I'm going to go fully through this. I'll probably just write in the greens that go with the pi over 3. But here, to get these, now our fraction for 1 is 4 over 4. We're going to subtract our 1 over 4. 4 over 4 minus 1 over 4 is 3 over 4, so we get 3 pi over 4. If we add it, we get 5 pi over 4 in this direction. Subtract it from now, 2 is going to become 8 over 4. So then this becomes 7 over 4 here. So lastly, when we're working with pi over 3, which is the radian measure that goes with 60, this would no longer be my fraction. I would use 3 over 3. So 3 over 3 for the 1 pi minus 1 over 3 would be 2 over 3, or 2 pi over 3. Adding it on, we would get 4 pi over 3. Subtracting it from 6 over 3, which is what we would use for the 2 pi, we would get 5 pi over 3. Now, I don't think I talked about this in the other video, but if you look in my second quadrant, you'll notice that all of the numerators on the fractions are 1 smaller than the denominator. And that is true because I've subtracted one of whatever they are, 1/6, 1/4, or 1/3 from the 1 pi that is the 180. In the third quadrant, all my radian measures are 1 bigger than the denominator, 7 over 6, 5 over 4, 4 over 3. And then in the fourth quadrant, because we were subtracting 1 from 2, one fraction from the 2, we're 1 smaller than double. So 11 is 1 smaller than 12. 7 is 1 smaller than 8, which would be double 4, and then 5 is 1 smaller than 6, which would be twice 3. So those are just a couple different ways you can think of those. We also know in those colors that all of the red radian fractions have the same denominator of 6, and so on. So those are little patterns you can look for. So now we're going to move out to the points. These are the points we knew from day 1. And this one is 0, -1. Sorry, I can't quite write it because of something on the video that's in the way. Now, moving around the circle, we want to first notice that from day 1, we knew that the y values are going to increase as we go up the circle as the x values decrease. And that was locating, which point has the biggest y, which point has the biggest x. We also now know that sine and cosine, specifically cosine first and then sine of each angle, is what goes on the points. So if I'm starting from 30, we know that the cosine of 30 degrees is radical 3 over 2, and the sine of 30 degrees is 1/2. We know the cosine of 45 degrees is radical 2 over 2, and so is the sine. And then when we come up to 60, we know the cosine is 1/2, and the sine is radical 3 over 2. And now if I look, I can see that my y values are increasing as my x values decrease 3, 2, 1. So we talk about how sine goes 1, 2, 3. Well, that also goes with the fact that the y is counting up as I go around the circle, and then the cosine goes 3, 2, 1, and that goes with the fact that the x is going back around the circle. When I move over to the other quadrants, I'm just going to copy the points for their colors, except I have to think about the fact, for example, that when I'm in quadrant 2, we have negative positive values, also something we did day 1. So if this point is radical 3 over 2, 1/2, this point is negative radical 3 over 2, 1/2. And then this point, same deal, but now we have radical 2 over 2 for both of them. And then moving up here, we have the point for 60, but the x is negative. Down in the third quadrant, everything's negative, but I should still match up with my colors. So I'm just copying those points. And we'll talk a little more about some other patterns we see once I get those on. So you'll notice everything is negative because we're in the third quadrant, but I still have those same values as the other green, red, and blue points. Moving over into the fourth quadrant. Now we have negative y values, right? Because we have a negative, I don't want to draw with the arrow because I already used the arrow for something else. We have a negative, sorry about that, a positive negative point value. So x is positive, y is negative, and we want that to be reflected in these points. And here we have 1/2 for x and negative radical 3 over 2 for y. So now, actually, when I fill out the unit circle, I don't fill it out that way. I really want you to get this idea of like all the angles that are close to the x-axis have the same values. So all the reds are the same, the ones in the middle, the blues are the same, and then the ones that are furthest from the x-axis are all green. They all have the same values. The idea being, if I were to draw triangles in here, all of these triangles, sorry if you hear kids yelling in the background, all of these triangles have the same base and height. They just might be going in different directions, okay? Because, which is reflected in the negatives or the positives or vice versa in each quadrant. But all of these triangles that are formed are the same because they're all 30 degrees from the x-axis. Now, when I count around the shape, I actually go in a circle. So I usually start with the y's, I don't know, to start with sines, and it goes 0, 1, 2, 3, and then all the way up to the top to 1. And I'll talk about that in a second, how that actually fits in the whole pattern. But then it comes down 3, 2, 1, 0, -1, -2, -3, down to its lowest, -3, -2, -1, 0. So it actually shows how the y values around the circle go up, and then they come down, and then they come back up as I go around. That's what the values do. The cosine values, I just go in a circle for the x's, and they're going back first, right, getting smaller. So I start here and I go 3, 2, 1. Then they go negative, -1, -2, -3 as they get more negative. And then -3, -2, -1 as they head back to the middle, to 0. And then 1, 2, 3. And I'm just talking about those numerators like we see in the patterns. So really, even though if I counted, I probably have, I think it's something like, 64 pieces of information to remember when I look at this picture. I don't ever think of it that way. It's really just patterns. Really the only thing you need to know is the first quadrant, and then the rest of it just comes from there.